Welcome everyone. I would like to present my PhD thesis title, which is the evaluation of mechanical and antipathogenic characteristic of dental polymers. My name is Lilien Nagy. I work at the Department of Prosthodontics, and my mission to decrease the incidence of denture fracture and the denture stomatitis, and my vision to develop a denture-based material with both antipathogenic and good mechanical properties. I have two specific goals, and my first goal is the evaluation of flexural strengths and the antimicrobial characteristic of polymethyl metacrylate incorporated with silver nanoparticles. Nowadays, 19% of the population wear removable dentures, and the most common denture-based material is the polymethyl metacrylate. But the most frequent failure is the fracture of the denture and the denture stomatitis, and we would like to enhance these properties by incorporating nanomaterials. And I have chosen the silver nanoparticles because it is known it has an antimicrobial effect. And our aim to assess the effect of silver nanoparticles, addition to PMMA, on mechanical and antipathogenic characteristics. My clinical question: how does incorporating silver nanoparticles affect the flexural strengths and the antifungal characteristic of dental acrylic resins? You can see here my PICO framework and my hypothesis. The flexural strengths of dental acrylic resin with silver nanoparticles is not inferior to the dental acrylic resin without silver nanoparticles. And my second hypothesis is the acrylic resin with silver nanoparticles the antifungal characteristic of dental acrylic resin with the silver nanoparticles is superior to the control group. I have finished my systematic search, and I have found more than 13,000 articles. And after the selection, 32 articles remained. And I have finished the data extraction, and we are waiting for the final results and figures. And while the statisticians are working on the final figures, we move on the risk of bias assessment. I have two ongoing analyses: the antifungal effect of Candida albicans and the biofilm measurement, and I have preliminary results for the flexural strengths, and the statisticians working on the final results, which will be a meta-regression analysis. But today I will show forest plots, which are preliminary results. I have 7 forest plots for each silver nanoparticles concentration, but because of the shortness of time, I will show one forest plot and a summary plot. So you can see here my forest plot, which shows the overall mean of flexural strengths. The flexural strength is a mechanical property which shows how the material can resist for bending forces. And there is an ISO standard for that. And if we would like to use the material for denture-based material as a denture-based material, it should be minimum 65 megapascals. And you can see here the overall means of the flexural strengths. We include, and it shows the group which does not contain any silver nanoparticles. And we included 14 articles, and all of them were in vitro studies, and the heterogeneity was really high. It was 100%. And the overall mean was 98 megapascal, and the confidence interval was between 87 and 108 megapascals. You can see here my summary plot. And on the left, you can see the concentration or the percentages of silver nanoparticles, and on the right, the overall mean of flexural strengths for each concentration. And I have highlighted two concentrations, the 0.05 and 0.2% of silver nanoparticles concentration, where the flexural strength was higher compared to the control group. And in case of 0.5% or above that, the flexural strength was not superior to the control group. And let's check the conclusion for the first outcome for the flexural strengths. At 0.05 and 0.2% of silver nanoparticles, the flexural strength was higher, which means we get a stronger material, and at a percentage of half and higher percentages, the flexural strength was lower than the control group, and we get a weaker material. And what were the implications for the practice? All of the evaluated materials can be used for denture base because all of them were above the ISO standard, and at 0.05 and 0.2%, the silver nanoparticles can decrease the fracture incidence. And what were the implications for the research? We would like to evaluate first the antimicrobial effect, whether in this concentration we gain an antifungal effect as well or not. And further implications are we would like to evaluate several mechanical properties and other nanoparticles as well. What were the strengths? The measuring of flexural strengths was standardized, and the production of the samples were made according to the ISO standards, and all of the articles used heat cure acrylic. And the limitations were the heterogeneity of the manufacturing of silver nanoparticles, and there were differences in the polymerization time and the size of the nanoparticles. And let's jump to the second topic, which is the evaluation of mechanical characteristic of polymethyl metacrylate incorporated with titanium dioxide nanoparticles. As I mentioned, the polymethyl metacrylate mechanical properties does not fulfill all the requirements, and still the prevalence of denture fracture is still high. It's between 10 to 20%. And in my second project, I would like to evaluate another nanoparticle, the titanium dioxide, and our aim is to evaluate the effect of titanium dioxide nanoparticles addition to PMMA on the mechanical properties. And my clinical question, how does incorporating titanium dioxide nanoparticles affect the mechanical characteristics of dental acrylic resins? You can see here my PICO framework, and we have more mechanical outcomes, the flexural strength, the impact strength, and the microhardness. And our hypothesis is the mechanical characteristic of dental acrylic resin with titanium dioxide nanoparticles are superior to the control group. And our clinical implication to improve the mechanical properties and decrease the prevalence of denture fracture. And you can see here the result of the preliminary searches. I have found overall about 8,000 articles, and after that my search key was accepted, so this will be my final search key. And to sum up, our planned submission date for the first project is September, and for the second project, January of 2025. I would like to finish my presentation with a quote. Success is the sum of small efforts repeated day in and day out. Thank you for your attention.
Regarding your first topic, you have only included single-arm studies?
Yes.
Okay. So maybe just in the conclusion, you should be a bit careful because you did a proportional meta-analysis where you're comparing, just showing your results and just comparing to a clinical threshold. So you're not doing any comparisons between groups. So just keep in mind that you're not comparing exactly to the control group. You're just showing each mean value compared to a clinical threshold that you have mentioned. So it's a bit different what you have done here. You cannot say whether one group was better than the other, but that the value of that X group, it's closer or closer to the clinical threshold that you have there.
Yeah,
okay.
Thank you.
Why did you choose the titanium dioxide nanoparticles in your second project?
The titanium dioxide is widely used in the biomedical field, and this is one part, and the others are the properties of the titanium dioxide nanoparticles, because of its non-toxicity, and it's chemically inactive, and it has proved antimicrobial effect as well, and it's relatively cheap.
If I saw it right on your forest plot, you have some articles that are the same as some articles below. Is there a reason behind it? Are they the same article, or is there any difference between them?
Thank you for your question. These were the same studies, and this is why, because they evaluated different brands, so all of them were heat cure acrylics. So this is why you can see some of the articles 3 times, because they evaluated three materials. And there is one article which were 2 times, because there the difference was the polymerization time. So one of the group was made by short polymerization, and the other is with long polymerization technique.
You said that the mechanical properties were better when the concentration of the silver nanoparticle was lower. So what do you think? Why is it in this way?
In the lower concentrations, maybe it's because of the size of the particles, because the PMMA molecules are bigger than the silver nanoparticles, and there are gaps between the molecules, and in the lower concentrations, the silver nanoparticles can fill these gaps. And above a certain concentration, maybe it's totally filled, and this is why after that mechanical properties get worse.
Based on your systematic search, there is no study which compares different concentration, like in one study, or does it exist? Because so far I understood you have only like single arm comparisons. Or you cannot compare it somehow statistically?
We will make a meta-regression, but we will evaluate other variables. But in all of the studies, the groups were compared with the control group, so without the silver nanoparticles.